This video is an introduction of the Rittal PMC-12 single-phase UPS. The objective of this training module is to give you an understanding of what a UPS does in a data center. To give an understanding of different UPS types and why it is important to choose the right type of UPS for a data center environment. To introduce the Rittal PMC-12 and give an overview of its features and capabilities. These topics will be covered in this training module. Purpose of a UPS. Risks posed by a poor quality mains power supply in a data center. Different UPS types. UPS power ratings. Rittal PMC-12 features. Available PMC-12 models. Internal and external batteries. Location of ports, fuses and switches on the PMC-12 models. The UPS, or uninterruptible power supply, is a crucial component in a data center. The main purpose of the UPS is to automatically switch over to battery backup power, whenever the mains power supply is not available. This backup power source is essential to maintain an uninterrupted power supply to equipment in the data center during power outages. Even when a generator is available as an alternative power supply, the UPS is still needed to keep sensitive equipment powered during the generator startup phase. However, depending on the type of UPS used, it can also protect connected equipment from a poor quality mains power supply. The quality of the mains power supply can be suboptimal for several reasons. Spikes. These are very short and sharp voltage increases, above the rated peak voltage of the supply. Spikes can damage hardware and corrupt software. Surges. Momentary voltage increases above the rated peak voltage of the power supply. Due to their relatively long duration, compared to spikes, voltage surges can degrade a computer's switched mode power supply components and lead to premature failure. Sags. Momentary voltage drops below the rated peak voltage of the power supply. Sags can cause a computer to reboot, if the mains voltage falls so low that the computer believes it has been switched off. Electrical noise. Very high frequency oscillations superimposed on their supply sine wave. This can be caused by lightning strikes, load switching, cable faults or nearby radio frequency equipment. Electrical noise can cause data corruption and hanging computers. Harmonics. Deformation of the sine wave, generally caused by nonlinear loads, which draw current from the mains supply in large peaks. Harmonics can cause a rise in current drawn from connected equipment, resulting in increased temperatures, followed by potential overheating and component failure. Brownouts. Long-lasting decrease in the peak voltage, below the rated voltage of the power supply. Brownouts can last for hours, depending on the response from the power supplier, and can cause overheating and component failure in connected equipment, and cause computers to reboot. Blackouts. These are momentary or longer-lasting cut-offs of the power supply. All these conditions have the potential to cause malfunction in sensitive IT equipment. As we will see in the next few slides, protection from a poor quality power supply can only be ensured by choosing the right type of UPS. There are different types of UPS on the market, with different characteristics in terms of output quality and stability. These are some commonly used terms for describing different UPS types. Standby, or offline. line interactive, or interactive. True online, or double conversion. The standby, or offline, UPS has a square wave output, which is often referred to as a modified sine wave output. When utility power is available, it is supplied to the connected equipment through a bypass switch, and the AC input is simply passed through to the output. When the AC input fails, the battery-powered inverter outputs a stepped square wave, forming a crude approximation of a sine wave output. UPS devices of this type are often cheap, but the stepped square wave output introduces high-frequency noise to the connected equipment, which is likely to cause malfunction and even permanent damage to sensitive IT equipment. There is also a changeover time between the failure of mains power and inverter startup, which can cause IT equipment to reboot. A better UPS solution for a data center, compared to the standby UPS, is the line interactive, or interactive, UPS. There are models of this type of UPS with either modified sine wave output, or true sine wave output, which is the only output type appropriate for a data center. Similar to the standby, or offline UPS, during normal operation, the line interactive UPS passes the AC input through a bypass switch to the output. But the line interactive UPS also includes a voltage regulator, capable of smoothing out spikes in the supplied AC power before feeding through to the output. However, like the bypass UPS, the line interactive UPS does not protect equipment during the changeover time between failure of mains power and inverter startup. The best solution for a data center is a UPS featuring true online double conversion technology. The PMC-12 falls into this category. The double conversion refers to the way the UPS functions during normal operation. Unlike the two previous types, a UPS featuring true online double conversion technology does not simply pass the AC input through a bypass switch to the output. Instead, the AC input is only fed through a rectifier to the DC battery charger. This means that even during normal operation, when the AC input is in fact available, the inverter is always powering the output and continuously performing DC to AC conversion. This double conversion enables the UPS to provide a stable and glitch-free, true sine wave AC output to the connected IT equipment, regardless of the waveform quality of the utility or generator supply. There is another crucial advantage of a UPS featuring true online double conversion technology, compared to the standby or line interactive UPS types. A UPS featuring true online technology does not suffer from a changeover time between mains power failure and inverter startup. IT equipment is always powered, since the output of the inverter is always active. UPS power ratings are often described in kilovolt amps, or kVA. This rating takes into account both the real and reactive power components of the connected equipment. kVA is referred to as apparent power. To illustrate the concept of apparent power, let's use the analogy of a glass of beer. Assume the whole glass of beer represents apparent power. It is the total amount of beer, or power, that you can transfer, or drink. The liquid beer in the glass represents the real power. This is the portion of the apparent power which can do the useful work, or be enjoyed. The foam, or head, of the beer, represents reactive power. This is the portion of the apparent power which is transmitted along with the real power, but it performs no useful work. Apparent power is often depicted in a diagram with the real power, which is measured in kilowatts, along the horizontal axis. The reactive power is indicated on the vertical axis. To find the representation of the apparent power in this diagram, you draw lines from the end of the arrows representing reactive and real power. The apparent power, which is measured in kilovolt amps, or kVA, can be drawn where these lines intersect. The angle between the apparent power and the horizontal axis is called the power factor. The relationship between volt-amps and watts is described by a simple formula. Watts equals volt-amps times by the power factor, PF. Without going into too much detail, let's look at a simple example. An old-style non-power-saving incandescent light bulb is always rated in watts. This is because the light bulb is a pure resistive load, and it has a constant power factor of 1. So, from the above formula, it is clear that the volt-amp rating of this light bulb is the same as its rating in watts. Inductive loads, on the other hand, such as a vacuum cleaner or the fans in a server, has a variable power factor, which means that its apparent power draw has both a real and a reactive component. For example, let's take a vacuum cleaner with the following rating: a load of 1.2 kilowatts, and a power factor, which equals 0.8. We can find its kVA rating from the above formula. Since volt-amps times by the power factor equals watts, it follows that volt-amps equals watts, divided by the power factor. So, in this case, the volt-amps equals 1200 watts, divided by the power factor 0.8, which equals 1.5 kVA. Similarly, for a 2 kVA UPS with a power factor of 0.8, the formula reveals that it supports up to 1.6 kilowatts. Since 2000 multiplied by 0.8 equals 1600. Now, let's take a look at the features of the Rittal PMC12 single-phase UPS. The Rittal PMC12 features true online double conversion, true 240-volt sine wave output, wide input voltage window to minimize battery operation, lighting and surge protection, automatic static bypass switch. The same unit can be mounted either vertically, as a tower, or horizontally in a rack. To accommodate the different orientation of the unit, the large LCD display is rotatable. The flexible design of the PMC-12 allows scalability from 1 kVA UPS to 30 kVA UPS just by adding modules. The 6 and 10 kVA units can also be paralleled, for N+1 configuration. The PMC-12 comes with a card slot, configured to accommodate an optional SNMP or relay card. The PMC-12 also supports USB and RS-232. A free monitoring software is provided. The UPS monitoring software can be used to configure the programmable outlets. It also features a graphical interface showing battery status, input and output voltage, and expected autonomy time, and many more features. The 1, 2, and 3 kVA models include internal batteries and allow plug-and-play installation with hot swappable batteries. The 7 amp-hour batteries have a 5-year life cycle and are easily exchanged from the front. Storage capacity can be increased for these models by adding external battery packs. The 6 and 10 kVA models need external battery packs, which take up 2 rack units. These models can also be paralleled with an optional parallel kit. The 2 and 3 kVA models of the PMC-12 are also available in a compact form factor. The PMC-12 Compact is technically identical to the standard PMC-12. It uses 4 rack units, instead of 2, and has a depth of 420 mm, instead of 620 mm for the standard model. The rear panel of the different PMC-12 models have some slight differences. You find a USB port for connecting the UPS to a PC. There is also an RS-232 port for serial communication. The emergency power off input allows dry contact signal inputs. An optional SNMP or relay card can be fitted in the communications card slot. External battery packs can be connected to the external battery connector. The AC power connection socket is used for connecting mains power to the UPS. A number of AC outlets are provided to connect equipment to be powered from the UPS. The programmable outlets can be configured using the free software. The programmable outlets can be used for connection of uncritical loads. These outlets can be configured to automatically switch off when certain conditions have been met. This could prolong the autonomy time for critical loads during a mains power failure. The input of the UPS is protected by a fuse fitted in the AC input fuse holder. Depending on the model, the PMC-12 is fitted with 1 or 2 cooling fans. The outlets of the 3 kVA model are protected by fuses fitted in the outlet fuse holders. This model also has a fuse holder for the programmable outlets. The rear panels of the 6 and 10 kVA models are identical. You find a terminal resistor used for paralleling PMC-12 units. The communication port provides a true RS-232 serial interface, which can be used with the free software to remotely monitor power and UPS status. There is an emergency power-off port. The AC input circuit breaker is a feature unique to the 6 and 10 kVA models of the PMC-12. So is the CAN bus port, which is used as a data interface when paralleling PMC-12 units. External battery packs can be connected to the external battery connector. There are 2 cooling fans. The 6 and 10 kVA models feature a combined AC input and UPS output power connector. Since these models do not have standard outputs, like the 1, 2, and 3 kVA models, a sub-distribution board may be required for connecting the loads. The Customer Options slots allows connection of optional interface cards, such as a second RS-232 port, an RS-485 port, or an SNMP card. As shown in this video, the PMC-12 is a flexible UPS solution which can easily be customized to suit different needs. The PMC-12 is available in 1, 2, and 3 kVA models with integrated battery storage. Storage capacity can be increased for these models with the use of external battery packs. The 2 and 3 kVA models are also available in a compact form factor. The PMC-12 is available in 6 and 10 kVA models. External battery packs must be used for these models. All PMC-12 models feature true online double conversion and true 240-volt sine wave output. In this training module, the following topics have been covered. Purpose of a UPS, and why it is needed in a data center. Risks posed by a poor quality mains power supply in a data center. Different UPS types, detailing what sets them apart. UPS power ratings, showing how to convert between kVA and watts. Rittal PMC-12 features and capabilities. Available PMC-12 models. Internal and external batteries, and how to change the internal batteries. Location of ports, fuses and switches on the PMC-12 models. Thank you for watching, and good luck with your PMC-12 single-phase UPS from Rittal.